Good day everyone and welcome to another senior high school lesson in statistics and probability. Are you now ready to start? Let's go. So now we are done with the sampling and different techniques. We are going to proceed the sampling distribution. Here is our objective. At the end of this video, you are expected to distinguish between parameter and statistic. Another one, we're going to identify the sampling distribution of statistics or the sample mean. So hello again students. Let us now proceed. But first, let us define this. Sloven's formula. This is used to determine the sample size in statistic and parameter. Statistic is a number which describes a sample, while parameter is a descriptive measure of a population. Another one is the sampling distribution. It is a probability when all possible samples of size n are repeatedly drawn from a population. So before we proceed with the sampling distribution, let us first differentiate parameter and statistic. So for the parameter, we are going to use population mean as a sample. Other than that, we have population standard deviation and population median. For the statistic, we have the main sample of that is the sample mean, wherein it serves as an estimator for the population mean. Other samples of statistic is sample standard deviation or the sample median. And to determine the sample size, we have the so-called Sloven's formula. So we have n is equal to n all over 1 plus n e squared, wherein our n, small letter n, is the sample size. Capital letter N will be represented by the population size, and E is the margin of error. Let us try to determine the number of samples using this problem. Given that the number of population is 12,000 with a margin of error of 5%, what is the sample size? So we are going to apply the Sloven's formula. So we are going to substitute the values based from the given formula. What will be the answer now? Solution will be 12,000 all over 1 plus 12,000 multiplied to the quantity of 0.05, which is expressed from percent and then squared. Then you're going to simplify the answer. So your sample size would be 387. So it means that will be the number of samples that you're going to get from the population size of 12,000. Did you get it right? Wow, very good. You may also try this problem using the Sloven's formula. Find the sample size required from a population of 10,000 with a margin of error of 5%. After determining the sample size, we can now proceed to the sampling distribution. It is a probability when all possible samples of size n are repeatedly drawn from a population. Are you ready now? Let us try and learn this sample. Construct a sampling distribution of the mean for the set of data below: 86, 89, 92, 95, and 98. Let us follow the steps. Step number 1. Solve for the population mean. We all know that we can solve for the population mean by getting the sum of all the values of x divided by the total number of the population. So to solve, we have the mu is equal to the summation of x over n. So we have 86 plus 89 plus 92 plus 95 plus 98 all over 5. The sum of all the numbers is equal to 460 divided by 5. That is equal to 92. So our population mean mu is equal to 92. Second step is to construct all the random samples consisting of 3 observations, which is our n is equal to 3 from the given data set. After that, you're going to arrange it in ascending order without replacement and repetition. Afterwards, you're going to get the sample of each random sample just like in this table. So we have a column for the random sample, which is n or 3 observations, and the sample mean. So since this is without replacement and repetition, we have a total of observations of 10. So say for example, in the first row, we have 86, 89, and 92. So this is a total of 3 observations. And then we're going to get the sample mean, which is the summation of x over n. So meaning we are going to add 86, 89, and 92. So a total of 267. And this will be divided by 3, which is equivalent to a sample mean of 89. And then just continue the process until the last observation. So now let's proceed to step number 3. We are going to construct the sampling distribution of the sample means. This is the continuation of your table in step number 2, wherein we have the sample mean column and its probability on another column. So in here, you are going to determine how many of the samples appeared in the sampling distribution table. As you can observe that 89, 90, 94, and 95 appeared only once in the distribution table, wherein its probability is equal to 1 over 10, meaning we have it only appeared once in the 10 observations. And also, we have 91, 92, and 93 that appeared twice, so its probability will be 2 over 10 or 0.2. You may also recall that the total probability of all the sample means must be equal to 1. So now let us proceed with step number 4. In here, you're going to construct the histogram for the sample means. So you can observe that this is a representation of your distribution table. Now we are all done. Let us recall the steps in constructing a sampling distribution. We have step number 1, solve for the population mean. Step number 2, construct all random samples consisting of the number of observations from the given data set. Arrange the observations in order, then get the sample mean of each random sample. Step number 3, construct the sampling distribution of the sample means. And lastly, you can construct the histogram of the sample mean. I think you are now ready for another exercise. Use the set of data below to construct a sampling distribution of the sample mean. We have 123, 126, 129, 132, and 135. This is located on your learning activity sheet, page number 6. Good luck! I know you can do it! I know that you are ready to sum up our lesson for today. We have number 1, differentiate parameter and statistic. Second, how to use the Sloven's formula. And lastly, how to construct a sampling distribution of the sample mean. So that ends our lesson for today. For questions or clarifications, don't hesitate to contact me, Ma'am Grace. Again, thank you for joining today's class. See you again next time. Stay connected and stay safe. Bye!